My name is Rich Luster. I'm honored to have been invited to share with this group of my highly esteemed colleagues some of the new and exciting approaches I have introduced to Hawaii's Department of Transportation's Bridge and Tunnel Inspection Program. The Bridge Inspection Program now maintains, repairs, and replaces all its bridges through the Bridge Inspection Program. All the advice and all the material that we bring up in our BRM and the videos and pictures we've been taking with the drones is now being used to create a better rehabilitation and replacement program. It's an exciting time to be an engineer throughout the industry. So many new building and design ideas being tossed into the cauldron of creativity. New formulas of concrete coming out of the kitchen every day, high strength, quick setting concrete additive formulas, even 3D printing on, here's some of the drones, the very first drones we've implemented, the DJI Pro 3. We added a new camera to it so we could get better visual off of it. The camera on it now, we can be 15, 20 feet away from a structure, and with a touchscreen laptop software, you can actually draw in as if you're an inch away from what you're looking at. So it really is, it's nice not having to be there. I'm going to explain more about that drone. The open ROV to the right is the first underwater drone that we purchased to operate and see what would happen if we went underwater and took a look at our columns and scour. And to be honest with you, it's been a real help not having to jump into the water, utilizing the open ROV. Now we are upgrading. Everything that we're doing now, we're upgrading because of the positive reinforcement we've had from the video and pictures we've been taking with these units. Here's something I want to throw at you just because my presentation is going all over the place. Technology is what I'm all about. Saving money and safety is what I'm all about. I was researching and I found that the University in Amsterdam is actually creating a 3D crossover bridge to an island in the middle of a pond. I thought that was really interesting to see that everybody's using technology in a way to bring us forward. Here's the Ihilaukea. This is the very first bridge we used our aerial drones to take pictures of and formulate how to repair, replace, or rehab this particular structure. The structure I failed. I failed the structure, and it's a highly traveled roadway on the northeast of the state of Hawaii, of Oahu. It's over by Hanauma Bay. Has any of you been to Oahu? Let me show of hands. Anybody? Wow, you guys got to get out more. It's a beautiful side of the island. On a clear day, you can see Maui, Lanikai, and the Big Island. And during the wintertime, it's beautiful to see the Big Island with snow on top. Again, I'm sharing fun stuff with you. That's one of the things I'm here for. Through the visual pictures and video that we've gotten from the drone, we had our structural engineers, myself, civil engineers, and the bridge inspectors all sit in on a preview of these videos. Through that, within a short amount of time, we decided not to replace because we can't lose the highway. That part of the island, economically, if we were to have closed that down for 3 months, all the businesses on that side of the island would have failed. So we had to come up with something where we didn't even have a lane closure. And through everyone looking at the visuals from the aerial video, we decided to rehab the bridge. The bridge only took about 1.5 months to 2 months to finish, and nobody knew we were underneath doing the repairs, other than the gangway we had up top to walk down to the scaffolding that was put underneath. And again, this was all using the aerial, working together, seeing and not having to go down there countless amount of times and coming up with what we wanted to do. Here's another still. This is a still taken from a video. This is just a still shot taken from the video from the software that comes with the aerial drones. Again, here's another one. This is when it was completed, the carbon fiber wrap that I brought into the state of Hawaii to use now. We use that for a lot of seismic retrofits. And again, I'm going all over the place. It's all about safety, not closing lanes, not spending the money on that, and keeping the inspectors and the people of Hawaii safe all at the same time. Again, here's another one finished, and this was taken from aerial footage from the drone, the very first drone we used. Unicompartmentalism is the direction we were going to go originally with the bridge, and we decided not to, again, because of the footage we had received from the drone. I can't tell you enough how much safer it's become the full year of 2016 we've been using the drone. It's stopped having us to close highways to set up rigging so that we can step over the side and rappel down and inspect the bridges. Now it's a matter of, wow, the drones are doing so much and we can get so close to it. If we find an area through the aerial footage of the drone that needs to be addressed, we only have to spend a short amount of time on the roadways with lane closures, having to rappel down or use a reach all, if ever, the way things are working. Again, I'm here to show you that the drones are saving us money, keeping us a little safer on the highways, and that's what I'm all about. We all know this, correct? Everybody knows this one. We've all done this if we're true inspectors. We've all done the rigging, we've all done the climbing, we've all done the diving. I actually kind of like that. The new technology that we have, I happen to have one of these now with the use of the aerial and underwater drones. This is such a great tool to go right from the visuals of the aerial and underwater drones and do a quick rendition of let's repair, let's replace immediately. The information that we're getting to design group now is not just the BRM report from the inspection. Now it's a full video plus the BRM and the recommendations immediately. We have a sit down, and within an hour of everybody speaking, okay, this is what we're going to do. Either we're going to sub it out, have it done, or we're going to design it in-house and get it repaired and replaced. This is my dream, to have one of my walls in my office with an 8x10 that I can walk around and go, you know what, I want to build this, I want to do that now, and then my 3D printer on the side that can do a same 8x10 rendition of the structure we want to build. So, hey guys, we could do this right now. I'm very much into technology because of the savings down the road. It might cost a lot up front, but the savings down the road is what's important, and the safety is what's important. I find that the visual for design, all us structural engineers, I find that the visuals are helping more because we're all sitting together looking at it. Here's something I thought was off the hook. This is an entire house. Again, technology. This was an entire house, 3D printed, right there. I thought that was the most interesting thing. Again, I'm throwing technology at you. Okay, here are the very first video pics that we took of the Ihilaukeia with the very first drone back in 2015. I mean, this was rough beginning with the aerial drone. But the video and the footage gave us this. This is what we sat down with the video and took a look at and said, you know what? We're going to have to replace it, but the abutments were good. So we decided, is there another way we can go? And this all happened within a room of less than 2.5 hours. Because of the video and the tangible feasibility of looking at the aerial videos from the drone, it just made, you know, what we wanted to do that much easier. Again, here's another snapshot of the bridge, carbon fiber wrapped from the aerial drone. I'm just, again, showing you some pictures. Okay, if we would have gone in the direction at the time of the first use of the drone and had the bridge replaced back in 2015, our cost would have been $15 million. We would have had to close or above, we would have had to close the highway for an indefinite amount of time. The contractor told us 3 months. And that's without having to disassemble the abutments. Okay, that's with saving the abutments. It still would have been 3 months. We would have closed a major artery for tourism and businesses on that side of the island. And I love going to that side of the island just to use the beaches. If we had kept going, this is the important thing. When they first asked me to come on board, I kept trying to find out ways, how can I streamline our costs all the way down the line? 95% of all the bridges in Hawaii were inspected by outside contractors. The average back in 2008, 2009 was $2,500 to $3,500 for a baseline bridge inspection, a baseline, no load ratings, nothing, just a baseline walkthrough. That's what they were charging us. 1,200 bridges in Hawaii, 600 bridges per 24-month cycle. You're talking about 1,200 bridges every 2 years. That was $1.5 to $2.5 million we were spending by outside subcontractors doing that. And I was trying to save some money on the other side. Not taking work away from the contractors, but how can I make it safer, bring some of that cost back into the house so we can immediately repair, replace, and rehab some of these bridges. And it's become successful. If you look at here, if we had kept going, right now we would have been at $8 to $10 million because it's increased from back then 200% of what it would cost to have outside contractors do the same amount of bridges. This is my pie. I love this pie. As of 2016, these are the actual numbers for us. Our budget for bridge inspection for the 1,200 bridges is $4.8 million. Because we're starting to use the drones underwater and aerial, it's cutting the cost in so many areas in the way of lane closures, in the way of police department support, even having the reach alls out and the manpower that we need for that and the crews that need to run that. Plus, if we have to set up rigging or scaffolding underneath these bridges, this is cutting all of this out. We're only attacking the areas through the aerial and underwater drones that need to be addressed because the visual findings we're finding through the videos. Okay, it's really starting to cut down. It's like you going to the dentist. You don't have cavities in all your teeth. You only have a cavity in one tooth. That's the tooth you fix. You don't bother with the others because they don't need it, correct? Okay, now we have an abundant fee just for the bridge inspection side that I can immediately tap into. If I find a bridge that needs to be rehabilitated or repaired, I can immediately go into my account and get it done. I don't have to go and get POs approved. I know we all have to wait for these POs from the state, and the accounting office is going, okay, yeah, 3 months later, okay, here's the couple of dollars we're going to give you. I can go right into my account now because of what we're doing with the aerial and underwater drones. It's showing that we have a better process and a more regulated way of spending the money, and we have the proof by the videos that we're getting from the aerial drones. This is kind of interesting because of what's happening. I spend a lot of time talking to high school and college students that are planning on becoming engineers and pre-engineering students, whether mechanical, technical, or software engineers, or structural, or civil. The minute that I bring up aerial and underwater drones, when I talk to them about what we're doing for the state of Hawaii, their eyes light up. It's like a new class. I spend more time answering questions because, what can we do? How can we get involved? So throwing the technology out there for these students is going to open up a lot of doors in the way of bringing up bottom lines for engineering departments, engineering firms, even construction companies that want to get into inspecting and helping us. There are, how many bridges? 600,000, over 600,000 bridges in the United States. It doesn't matter how many people we put together. We're not going to handle 300,000 bridges in a 12-month period. It's impossible. So we need some help, and we need more teams. That's not going to cost as much as setting up the rigging, getting the lane closures that we need, setting up scaffolding, getting the reach alls out there. We can put people on the ground in a minute, just like when we would do a halo shoot for Special Forces. Boom, we're on the ground, we make it happen, we're done. That's what we're looking. Get the information to design as soon as you can so we can find out what funds we need to get things done. This is just a drone dropping off college degrees. I threw this together because I've been spending a lot of time with college students, and I just thought it would be interesting. Here we go. We're going to have some fun now. This is the famous 20-year longer than it should have taken tunnels on Oahu that connects the Honolulu side to the Kaneohe side. This video was taken with the drone. Some of these videos that I'm going to show you right now, it's just for fun for you guys. Show you a little bit of Hawaii, get you a little bit like, oh, wow, this is cool. This is only about 100 feet up. So, you're just getting to take a look at what we've been doing. Here's the Kaneohe side, just to, again, give you a little visual of the aerial drones. I don't have any underwater because I didn't want to bother with that because it's kind of involved. We're still in the water with the drone because we're learning how to use it. Mid-2016 is when I introduced it, and we're still kind of, ironing out all the bumps. What I found the day they were shooting this, after I was done, we had a little landslide. You see the pocket to the left of the screen here, that little pocket? A couple of big boulders rolled down, and it just so happens I was on site. I flew in, took a look at, and we saw that you know, the degradation on the side of the mountain, which we've been having a problem with, I happened to be there at the right time. So it was really interesting that we were able to get some footage that I was able to use. Okay, here's an interesting thing. I told you earlier, 15 feet away. This is 15 to 20 feet away from the structure. If you have the software on whatever tablet or laptop you're using with this device, you can draw in from 10 feet away and look and feel as if you're an inch away from what you're looking at. The software that comes with the new drones today allows you to do that. So when you snap a picture, you can see up close what's going on. I really like using the underwater and aerial drones. Again, saves time, saves money, and it keeps people safe. And again, that's what I'm all about. If I can get information, direct feed to design while we're out in the field, that's what I'm all about. Our bicycle path, our overhead bicycle path that's already at $8.5 billion. I don't know if anybody's been paying attention, but this is the railway system that they've been building in Hawaii. I wanted to show you this just to let you see this beautiful overhead bicycle path that we've been spending a lot of money on, because it's not going to be finished. It's not going to be finished in any of your lifetimes. Okay, I will say this, it's a nice bike path. No, it's from Kapolei all the way. I would ride my bike that 20-some miles because it's away from traffic. Here is our first night. I designed some lighting, some real nice high loom lighting to attach to the drone. We couldn't walk away. We were up all night shooting video of the drone at night. As a matter of fact, the news called us because there was an accident. About 2 weeks later, they found out that we blah, blah, blah. We went out and we shot some of the footage of the actual traffic with this. We were having so much fun. The fire department, I've been working with them now, and the police department. So it's just interesting what you can do with the drones that might not even have anything to do with it if they're finding out your program is becoming successful. Okay, I recommend highly having a learning curve SOP. Okay, 100 hours is not enough. This is what I created back in 2015 because I saw what the inspectors and the engineers were going through operating these systems. Fresh out of the box, I don't care how much you play with your drone at home with your children or it's a hobby of yours. Underneath a bridge, in between columns, going through caps, in between open girders, the density of the air changes, updraft changes. You have to become proficient at this to make this work for you and become effective. What's on that board right there, I will share with everybody just to give you a baseline to start with, but it's a great tool. The underwater and aerial drones are great tools, okay? It is not a toy. That's one thing I found out with the HPD and the fire department for the state of Hawaii. Introducing them to this and working with them, helping them create a program of this aerial and underwater drone, they went out and bought top line. I mean, $12,000, $14,000 units. They lasted about 2 to 3 weeks because they took it out of the box as a toy. Okay, there has to be this protocol in place, training has to be done, and the right people have to be put in place that understand how to use it. Ergo, when I'm talking to the students, as I mentioned earlier, they were hyped. It made it even more interesting. Oh, wow, this is the direction we have to go. This is the main reason why I'm here. This is what I worked on my doctoral with. The last 6 months working with mechanical engineers, structural engineers, and software engineers out at UH, I designed and created the IBEX. I'd love to share a ton of information with you, but I will say the working platform inspects the bridges, NDT, ultrasound, 3D imaging, and some other things that I can't share with you right now. When I get back to Hawaii, a group from Australia is coming down because they're really interested in the unit, and we haven't even shared it with anybody. They found out through UH. And then another group from Germany is coming down. They're interested. This is a 24/7 platform. I can work with it for 8 hours, keep it up, give it to you. You can work with it for 8 hours, nonstop, 24 hours a day, 7 days a week. This unit does not get hot. It marks the areas that need to be examined further or it marks the areas that need to be repaired or replaced. Here's my last slide, my big mahalo. I hope you got a little bit of the safety, the cost savings, and the direction I'd like to see us all go with the aerial and underwater drones. We're speaking to a company right now who happens to be here about bringing in some of their underwater drones because I feel from the research they're best suited for what we're looking to do. That was a beautiful skyline of Honolulu to Diamond Head. Just to have a little fun with you again. I wanted to have more fun with you than throw a ton of data at you because it's early in the morning, and again, I know where your heads are at. This is thanking the groups of people that were involved, giving us the information that we needed in order to get the numbers to share with you this morning. Much mahalos. I am here for you. If you guys need any help and you're really interested in adding this to your Department of Transportation programs, if you don't already have this in place, or you're an engineering firm and you're looking to add this on, wisdom means money. Bottom line will grow for you guys, construction companies, bottom line. Get into this and talk to the people that have been working with it and have the wisdom of what's going on with the unit because there's a lot of things you need to do. It's not open the box and fly it.